Ancient cosmic impacts have played a pivotal role in shaping Earth's history, leaving behind geological anomalies that tell fascinating stories. These celestial events, such as asteroid and comet collisions, have not only altered landscapes, but also triggered significant climate shifts. Imagine a time when a massive impact caused dramatic changes in temperature and atmospheric conditions, influencing the evolution of life itself. By exploring these ancient impacts, we gain valuable insights into how our planet has transformed over millions of years. Understanding these events is crucial as they reveal the interconnectedness of cosmic forces and Earth's geological processes, ultimately helping us comprehend the delicate balance of our environment today. Cosmic impacts primarily involve asteroids and comets colliding with Earth, each bringing unique characteristics and consequences. When these celestial bodies strike, they release immense energy, leading to significant geological changes such as craters, tsunamis, and volcanic activity. These impacts can also trigger climatic shifts, like the impact winter, where dust and debris block sunlight, causing global temperatures to plummet. Key scientific theories, such as the Alvarez hypothesis, suggest that the mass extinction event that wiped out the dinosaurs was caused by an asteroid impact. By studying these ancient impacts, scientists can better understand Earth's history and the potential risks posed by future cosmic events, emphasizing the importance of ongoing research in this field. One of the most notable ancient cosmic events is the Chicxulub impact, which occurred around 66 million years ago and is closely linked to the mass extinction of the dinosaurs. This colossal asteroid struck what is now the Yucatan Peninsula, creating a crater over 150 kilometers wide. Geological records, including iridium layers and shocked quartz, provide compelling evidence of this catastrophic event. The impact is believed to have triggered massive wildfires, tsunamis, and a nuclear winter effect, drastically altering the climate. Such historical impacts illustrate how cosmic events can lead to significant shifts in Earth's climate, reshaping ecosystems and paving the way for new species to emerge in the aftermath of destruction. Several key geological formations exhibit signs of ancient cosmic impacts, offering a glimpse into Earth's tumultuous past. For instance, the Sudbury Basin in Canada and the Vredefort Dome in South Africa are both massive impact craters that reveal significant geological changes. These anomalies provide valuable insights into Earth's climatic history, indicating how impacts have influenced temperature fluctuations and biodiversity. However, alternative hypotheses exist regarding the origins of these features, with some scientists suggesting volcanic activity or tectonic processes as potential explanations. By examining these geological anomalies, researchers can better understand the complex interplay between cosmic events and Earth's evolving climate, enriching our knowledge of planetary history. Ancient cosmic impacts have significantly influenced climate shifts throughout Earth's history, often correlating with major extinction events and environmental changes. For example, the Chicxulub impact not only caused immediate destruction but also led to a prolonged impact winter, drastically altering global temperatures. These long-term climate shifts have had profound effects on ecosystems and biodiversity, reshaping habitats and leading to the rise or fall of various species. Understanding these historical climate changes is crucial, as it provides context for current climate challenges. By studying how ancient impacts affected the planet, we can gain insights into resilience and adaptation, helping us navigate the complexities of today's rapidly changing environment. While mainstream scientific views often emphasize the catastrophic effects of cosmic impacts, several lesser-known theories challenge this perspective. For instance, some researchers propose that certain geological formations attributed to impacts may actually result from volcanic activity or tectonic movements. These alternative hypotheses encourage critical thinking about the implications of cosmic events, suggesting that Earth's history may be more complex than previously thought. By exploring these theories, we can gain a more comprehensive understanding of how various forces, both cosmic and terrestrial, have shaped our planet. This broader perspective not only enriches our knowledge of Earth's past, but also highlights the importance of ongoing research and open-mindedness in the scientific community. In this video, we explored the significance of ancient cosmic impacts and their profound effects on Earth's climate and geology. From the dramatic changes triggered by events like the Chicxulub impact to the intriguing geological anomalies that tell our planet's story, these cosmic encounters have shaped the course of life on Earth. Understanding these topics is essential for gaining a deeper insight into our planet's history and the forces that continue to influence it. If you found this discussion engaging, please subscribe, like, and share this video with others who might be interested. Don't forget to check out our related content for more fascinating insights into Earth's past and its cosmic connections.